Okay, now we're going to take a look at another system of linear equations in three variables. To start out, I'm just going to label this equation 1, equation 2, equation 3 so we can reference to them as we go. And what we did last time was we chose two of these equations at a time so that we could cancel out the x, the y, or the z. But this time we kind of already have something started that will make it a little bit quicker. Notice how equation 1 doesn't have a y in it already. So it's already down to just two variables instead of three. So what I'm going to do first is I'm going to take equation 2 and I'm going to take equation 3, and what I'm going to do is go ahead and get rid of the y variable from both of those. That way I can start out with two equations that have just the x and the z involved. So we're going to cancel out the y here. The way I'm going to do that is I'll take the first equation and I'll multiply that by -2. Changing it into -2x minus 2y minus 4z is equal to -34. The other equation, we're just going to leave it the same. There's going to be no change for that one. So we'll have x plus 2y plus z is equal to 16. And so that is going to cause our y variable to cancel out when we add these together. So that'll be gone, and we'll be left with -x minus 3z is equal to -18. And we'll call that equation 4. So now we can take the first equation and this equation and put those two together in order to continue to solve. Since they both only have x and z involved, we can go ahead and cancel out either the x or the z depending on how they look. And looking at them as they stand already, it looks like x is already good to go to cancel out. So we can just go ahead and add them together. The x will cancel. We'll be left with -2z is equal to -10. And so from here it's just one step away to solve for z. Divide out the -2. Z is equal to 5. So that's awesome. We didn't have to do too much work to get there. So what I'll do now is I'll substitute z equals 5 into equation 1 so that we can solve for x. So that would look like x plus 5 equals 8. And after subtracting over the 5, we'd see that x is equal to 3. Now we have x, now we have z. We can go ahead and substitute and solve for y. So we're going to substitute x equals 3 and z equals 5. And we can substitute this into equation 1, or sorry, not equation 1, but equation 2 or equation 3 in order to solve. Looks like I used equation 2. Looked like a fairly quick way of getting there. So that's going to look like 3 plus y plus 2 times 5 is equal to 17. That'll turn into y plus 13 equals 17. And after subtracting the 13, we'll find out that y is equal to 4. So that's our full solution. 3, 4, 5.